Good day everyone! Our today's lesson is a continuation of Newton's laws of motion. On our previous discussions, we have learned about Newton's first law and second laws of motion. Can you still recall what are these laws? The first law is also known as? Very good. While the second law is? So today, we will be discussing the third law of motion. Newton's first law of motion describes what will happen to objects in the absence of an external net force. Newton's second law pertains to behavior of objects if the forces are not balanced or if the external net force is not zero. At this point, let us review the sample computation of acceleration. So here is our problem. A 5 kilogram table is being pushed with a force of 20 Newton. What is the table's acceleration? Remember that in our discussion about the computation of acceleration on the previous video lesson, we have learned to use the mnemonics GAPSA, wherein we have G, which stands for the given, A stands for what is asked, F stands for the formula, S stands for the solution, and finally, A stands for the answer. In the given problem, our given are the following. The mass of the table is, very good, we have 5 kilogram. Kilogram is the unit of mass. The unit of mass is kilogram. The force that acts on the table is equal to 20 Newton. Newton is the unit of force. The unit of force is Newton. Then, we have to compute for the acceleration of the table. Then, our formula is acceleration is equal to net force divided by mass. Again, net force refers to the sum of all forces acting on the object. So, we will replace it with our given. So, we have 20 Newton, that is the net force, divided by 5 kilogram. So, the answer is 20 divided by 5. That is equal to 4. Yan. 4 meter per second squared. Meter per second squared is the unit of acceleration. I hope that you can now solve problems in acceleration on your own. Okay, at this point, let us discuss about Newton's third law of motion. Let's analyze this illustration. As you can see, there is a man pushing against the wall. When you push on a wall, does the wall also push you? According to the third law of motion, it does. This law states that for every action, there is an equal and opposite reaction. The law of interaction, or Newton's third law of motion, is also known as the law of action-reaction. Newton's third law explains that a force is due to an interaction between two objects. One object serves as the source of the action force, and the other acts as a source of the reaction force. In any interaction, there is an action-reaction pair of forces. These two forces are equal in magnitude, but opposite in reaction. Opposite in direction. One cannot exist without the other. Forces always come in pairs. One is the action, while the other is the reaction. These forces make up the interaction. Here are the properties of action and reaction pair of forces. Number 1. Action and reaction forces always come in pairs. So, yung action tsaka reaction na forces, palagi siyang magkapares. Isang action at isang reaction. Number 2. Action and reaction forces are equal in magnitude but opposite in direction. Remember that when we say magnitude, it has something to do with the strength of the force. And number 3, action and reaction forces act on two different bodies. And finally, number 4, action and reaction forces have the same line of action. There are some action-reaction force pairs that are evident in nature. Consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. Yung mga isda, ginagamit nila yung palikpik nila para itulak yung water backward. But a push on the water will only serve to accelerate the water. In turn, the water reacts. How does the water react? By pushing the fish forwards, propelling the fish through the water. So the action force is when the fins of the fish push the water backwards, and the reaction force is when the water push the fish forward. The size of the force on the water equals the size of the force on the fish, and the direction of the force on the water, which is backwards, is opposite to the direction of the force on the fish, which is forward. For every action, there is an equal in size or in magnitude and opposite in direction. So for every action, there is an equal and opposite reaction force. Action-reaction force pairs make it possible for fishes to swim. Next is, let us consider the flying motion of birds. Nakakita na ba kayo ng lumilipad na ibon? Paano kaya nakakalipad yung mga ibon? A bird flies because of its wings, of course. The wings of a bird push air downwards. So take note of that. The wings of the bird push the air downwards. In turn, the air reacts by pushing the wings of the bird upward. So the action force is when the wings of the bird pushes the air downwards, and the reaction force is the air reacts by pushing the wings of the bird upward. So next is, an apple falls as it is detached from the tree. An apple falls down as it is detached from the branch. The earth pulls the apple downward. So if the earth pulls the apple downward, the apple pulls on earth upward. So kung hinahatak ng earth yung bumabagsak na bunga ng mansanas or kahit na anong bungang bumabagsak or kahit na anong object na bumabagsak, in return, the object that is falling is pulling the earth upward. So in the case of an apple, the earth pulls the apple downward and the apple pulls the earth upward. Next is the earth pulls on the moon and the moon pulls on the earth. Remember that the moon exerts an equal and opposite reaction force on earth. So if the earth pulls the moon also pulls the earth. In your grade 7 class, you have learned that the gravitational pulls of the moon is responsible for the rising and falling of tides. Kaya meron tayong high tide and low tide. Next, we have action-reaction in sports. Let's start with archery. In archery, if you pull back a bow as an action, the bow will spring forward as a reaction. Di ba pag hinahatak natin yung pinaka-bow sa pana, pag binitawan mo, ang reaction niya is mag-move siya forward. Next, we have, are you familiar with this? Okay, dragon boat competition, boat racing. To row a boat, the boatman or the player of the boat racing pushes the water backwards with the help of the oars or the sagwan. This is the action force. The water, in response to the action force, exerts a reaction on the boat in forward direction. So, ginagalaw natin yung sagwan backwards. Then, tinutulak ng water yung sagwan forward. Kaya nagmumove tayo. Backward yung action, forward yung reaction. So, next is that we have here in swimming. Actually, this mechanism is also the same as the way the fish swims in relation to the application of Newton's third law of motion. In Newton's third law of motion, it states that for every action, there is an equal and opposite reaction. Thus, swimmers must stroke downward in the water to stay afloat and propel forward. This movement is equal and opposite to the force the water exerts against the swimmer to stop them from moving. So, next is we have here baseball. According to Newton's third law, again, the force exerted by the bat hitting the ball will be equal in magnitude but opposite in direction of the force the ball exerts on the bat. So generally, your arms are stiff when you hit the ball forward. So you will not feel the bat recoiling. But if you relax your arms, you will feel bat being shot backward the moment that it directly hit the baseball. That's all according to Newton's third law of motion. And lastly, we have soccer. In soccer, when you kick the soccer ball, you will feel the force of the kick back into your leg. You won't feel the force as much because your legs have more mass than the soccer ball. Pero pag una ka palang naglalaro ng soccer or anything that requires you to kick, medyo makakaranas ka ng you will experience pain on your legs. Pero pag you are already a pro player of soccer, hindi ka na masyadong sasakitan ng binti or ng hita mo kakasipa ng bola ng soccer. Okay, let us have an activity. It is entitled Rocket Science with Balloons. I know that you are familiar with rockets. And through this activity, let's find out how rocket works. The objective of this activity is to observe Newton's third law in action and learn how rockets work with this fun science activity. So for this activity, you will need the following materials. You have to have a balloon, at least one. Next is you have to have a straw, scissors, 10 to 15 meter string, and a tape. Be careful and precaution is needed in doing this activity because you will be using a sharp object which is a scissors. Let's have the steps. Step number 1. Tie one end of the string to a doorknob, table leg, or another sturdy object. So, manap kayo ng pwede niyong pagtalian ng string ninyo or ng yarn na matatag na bagay or hindi mabuhay, pwedeng sa upuan, kagaya nito, pwede din naman sa doorknob. Siguraduhin nyo lang na while doing this activity, walang magbubukas ng pintuan ninyo. So, that is the first step. Number 2. Pass the other end of the string through the straw and secure it to a second object that will keep the line stretched in place, preferably in an upward slant. So, ang gagawin nyo lang, yung string ninyo or yung yarn ninyo, ipapasok nyo dun sa butas ng straw. Like this one. So, ayan, nakapasok na yung string sa mga butas ng straw. And then, itatali nyo siya sa isa pang object. So, ang ginawa ko dito ay tinali ko siya sa upuan. Just make sure na dun sa kabilang side na itatali ninyo, medyo mas mataas siya ng pagkakatali compare dun sa isa. Para naka-upward slant siya. Medyo padaus-dus ba yung tawag doon? Nakapaling siya. Medyo naka-incline, pataas ng isa. Mas mataas yung isa. Next, inflate the balloon. Pinch it shut and tape it to the straw such that the mouth of the balloon is facing away from the direction in which the straw should move. So, gagawin nyo lang, hihipan nyo yung lobo. Pakiingatan lang, sobrang laki, baka pumutok sa mukha ninyo yung lobo. So, pag gagawin nyo ito, you have to seek the supervision of an adult. Patulong kayo sa kuya ninyo, sa ate ninyo, o sa kahit na sinong makakatanda sa inyo na pwede kayong i-guide. Then, after ma-inflate yung balloon, after nyo mahanginan, ite-tape nyo lang yung balloon sa may straw. Do not forget, wag nyo ibubuhol yung dulo ng lobo. Hahawakan nyo lang siya. Again, wag ibubuhol yung dulo ng lobo. So, you will find out later kung bakit hindi nyo dapat ibuhol yung dulo ng lobo. For the last step, bring the straw to one end of the string line and let the balloon go. Blast off! So, let us watch this video. This is an activity which was done during our class, nung meron pang face-to-face class. This section is, I think, 8 Mulawin, 8 Kamagong of my class, school year 1920. So, let's watch this video. Release. Nakita niyo ba yung nangyari sa lobo? So, panoorin ulit natin ng isa pa. That one. When the student releases the balloon, nung binitawan yung lobo, so yung lobo ay nag-move in a forward direction. Okay. Can you explain what happened? Can you write it on your notebook? Explain what happened. Where did the balloon get the energy to move from? Paano kaya or bakit kaya gumalaw yung lobo? Saan kaya galing yung energy niya? How does Newton's third law of motion apply here? How does this relate to the movement of rockets? Please write your answer on your notebook. Explain what happened. Where did the balloon get the energy to move from? How does Newton's third law of motion apply here? How does this relate to the movement of rockets? All right. Let us explain the activity. Here is the explanation. When the mouth of the balloon is released, the balloon shrinks back to its original size, pushing air out of the opening. So, nung binitawan yung lobo, may lumabas galing sa loob ng lobo. Ano yun? Lumabas na yun galing sa loob ng lobo. That is very good. Air. So, dahil lumabas yung air, nag-shrink na yung balloon. Na-deflate siya. Bumalik siya dun sa original na shape niya nung hindi pa hinihipan or wala pang hangin sa loob. As Newton's third law of motion states, for every action, there is an equal and opposite reaction. Therefore, as air rushes out of the balloon in one direction, the balloon is pushed forward in the opposite direction. So, habang lumalabas yung lobo, let's say, backwards, lumalabas yung hangin from the balloon backwards, yung lobo, nagmo-move naman siya forward. So, the balloon is pushed forward in opposite direction. This is the same principle that rockets use. Ganito rin yung principle sa propel ng rocket, sa pagpropel ng rocket. When rocket fuel is burned in the engine, hot gases are produced which rushes out of the back of the rocket. This in turn pushes the rocket forward. So pagka nag-apoy na, nagkaroon na ng burning of fuel sa pinaka-engine ng rocket, may lumalabas na mga hot gases. It moves downward. As a reaction force, the gases pushes the rocket forward. So when the rocket fuel is burned in the engine, hot gases are produced, which rushes out of the back of the rocket. This in turn pushes the rocket forward. So that is the principle in propelling rocket. Newton's third law of motion. So at this point, before we end this session, let us check your understanding. Question number 1. If you are launching a matchstick rocket, the action force is the rocket pushing the gases down. What is the reaction force? So, ayan na nga. Kaka-explain lang natin about the propulsion of rocket. So the choices are A, the table pushing the racket down, B, the gases pushes the racket up, the gases pushing the racket down, and the table pushing the racket sideways. Again, if you are launching a matchstick racket, the action force is the racket pushing the gases down. What is the reaction force? Here are your choices. 5 seconds. 5, 4, 3, 2, and 1. Answer is the gases pushing the racket up. So, pansinin natin na, ang action force natin is racket pushing the gases down. Again, racket pushing the gases down. So, ang reaction natin ay the gases pushing the racket up. So, if the action force is the movement is downward, the reaction force movement is upward. Kung ang gumawa ng action force ay yung racket, ang gumawa naman ng reaction force ay yung gas. Number 2. A ripe mango falls as it is detached from the branch. So, parang inexplain din ito kanina. The earth pulls the mango downward. What is the reaction to this force? A. The mango pulls up on earth with a greater force. The mango pulls up on the earth with an equal force. That's letter B. Letter C. The mango pulls down on the earth with an equal force. And letter D. The mango pulls down on the earth with a greater force. Okay, for this question, I will give you 10 seconds. Okay, take your time. 5, 4, 3, 2, and 1. Our answer is the mango pulls on the earth with an equal. Take note of that. An equal. Because Newton's third law is for every action, there is an equal and opposite reaction. And finally, number 3. According to Newton's third law of motion, when a hammer strikes and exerts force on a nail, the nail A. disappears in the wood. B. have friction with a hammer. C. moves at a constant speed. And letter D. exerts an equal force on the hammer. Please write your answer. Alright, time's up. The answer is letter D. exerts an equal force on the hammer. The nail exerts an equal force on the hammer. Okay, congratulations! We are done discussing Newton's laws of motion. Finally, natapos na natin yung first, second, and third laws of motion. Thank you for watching. See you again next time. Don't forget to subscribe, hit like, share, and hit the notification bell. Thank you, everyone. Shout out to Kuya Waning. Thank you for sharing my videos. Don't forget to subscribe on his YouTube account.